Building a manned quadcopter is not just about flight. It's about pushing the boundaries of technology, engineering, and design. But how do you go from a dream to a real flying machine? Let me take you through the essential steps to make it happen. It all starts with the concept. For a manned quadcopter, the primary goal is to ensure stability, safety, and the ability to lift a human being while maintaining control. This involves choosing the right motor power, propeller size, and battery capacity to carry the load. First, we focus on the propulsion system. In our case, we're using BLDC motors because they offer the perfect balance between power and efficiency. For a manned quadcopter, you'll need motors that can lift anywhere from 300 to 500 pounds. This means selecting the right motor size, propeller type, and making sure the battery can supply enough energy for flight times of around 20 to 30 minutes. Once we have the components selected, we move to the frame. We need something lightweight but incredibly strong. Carbon fiber is perfect for this. It's durable, lightweight, and resistant to stress. The frame also needs to be designed to handle the vibrations and forces generated by high-powered motors and propellers. Now that the frame is ready, we add the flight controller. This is the brain of the quadcopter, responsible for maintaining stability during flight. The ESCs, electronic speed controllers, manage the power sent to each motor based on inputs from the flight controller. These need to be carefully tuned to handle the heavy load and provide precise control, especially during takeoff and landing. Weight distribution is crucial. We use static equilibrium calculations and mass integrals to precisely determine the center of gravity and ensure the quadcopter remains stable throughout flight. While a symmetrical motor layout helps with balance, we also account for how the pilot's weight, along with the shifting energy consumption of the battery, will impact the overall balance as the craft moves through different flight stages. But stability isn't the only concern. For safety, we've integrated an emergency parachute system. This parachute is designed to deploy automatically in the unlikely event of a critical failure, whether it's a motor malfunction, a loss of power, or any other issue that could jeopardize the flight. The parachute ensures the pilot can land safely, giving them a reliable last resort safety mechanism. Now comes the tuning phase. The PID controller adjusts how the quadcopter responds to control inputs. This is where we fine-tune everything in simulation mode, simulating flight behavior, stability, and responsiveness before moving to real-world testing. After completing the virtual testing, we can finally move to real-world trials. The quadcopter should be able to hover, take off, and perform precise maneuvers, just like a regular drone, but with the added complexity of carrying a pilot. And that's it. The journey from concept to a fully functional manned quadcopter involves careful design, testing, and refinement. But with the right tools and a clear plan, you can bring your vision to life. Thanks for following along with me on this journey. If you want to dive deeper into the design process or see more behind-the-scenes footage, don't forget to hit subscribe and click the bell to stay updated. The sky's the limit, so let's keep pushing the boundaries together.